Most lakes on Earth share a remarkably similar, incredibly slow origin story. Glaciers, over tens of thousands of years, grind across continents, carving deep gouges into the bedrock before melting to fill them. Or, deep below the surface, tectonic plates slowly pull apart, creating massive rift valleys that gather local groundwater drop by drop over millennia. But some bodies of water bypass this slow terrestrial clock entirely. They are forged in a fraction of a second by violent collisions from space. This is Lonar Lake. It is a perfectly circular, deeply recessed body of water born directly from a meteor impact. Meteors strike every planet and moon in our solar system, but finding an intact impact lake like this on Earth is exceedingly rare. Our planet's active weather systems usually erase these surface scars quickly. To figure out how this specific crater survived the elements, we have to look past the water itself and examine the vessel holding it. The answer is buried in the ground. The ground zero for this impact site is composed almost entirely of basalt rock. When a hypervelocity space projectile collides with the terrestrial surface, the outcome depends entirely on what it hits. We need to decode exactly how this rigid, hardened volcanic rock reacted to a massive impact to forge a permanent, watertight basin. The incoming space projectile was a dense, incredibly heavy iron-nickel meteorite. It tore through the atmosphere carrying immense kinetic energy, traveling at tens of thousands of miles per hour. Upon impact, that kinetic energy transfers instantly into the ground. A violent shock wave pushes outward and downward, excavating millions of tons of earth in a process called mass displacement. Energy creates the hole, but whether that cavity collapses back in on itself or survives as a distinct crater depends entirely on the material resistance of the target. The region where Lonar is located is made of basalt that cools into tightly packed, highly rigid hexagonal columns. If a meteor strikes loose sedimentary soils or sand, the ground behaves almost like a liquid. It absorbs the blow, but the edges of the crater quickly slump and cave in. The extreme density of the basalt at Lonar resisted the later stages of the shockwave. Instead of absorbing the energy and collapsing, the rock shattered outward. Because the basalt walls were rigid enough to hold their ground without slumping, the crater maintained its steep walls, isolating it as a geological anomaly. The extreme pressure of the collision compressed the bottom of the crater, creating a fractured but highly dense, non-porous bowl. Liquid cannot seep through this barrier into deeper earth strata. Over the centuries, monsoons and local groundwater gradually filled this newly formed impermeable rock basin. The violent collision excavated the stone, and then the process forged a permanent vessel that allowed a completely isolated aquatic environment to emerge right out of solid rock. Today, the site of this massive kinetic explosion is quiet, supporting a serene, static ecosystem. The exact circular shape of the lake remains strictly dictated by the unbroken basalt rock walls surrounding it. We are looking at a rare physical record where cosmic iron collided with hardened terrestrial magma and found a precise point of stabilization. Lonar is the ultimate basalt exception. It stands as a physical monument to what happens when space debris strikes the hardest parts of our planet. Earth's most striking features are usually dictated by millions of years of gentle erosion from water and wind. But occasionally, a sudden, violent impact against unyielding rock is exactly what is required to create a permanent, anomalous wonder.